Greetings. On the practical lesson of the function blocks, as we dealt with the gates, I want us to go through the practicality of using the gates in demonstration of function blocks. As we have discussed yesterday, the first thing that you need to do, you will select the type of a CPU that you want to use. And then, as we discussed, your power supply, your CPU. In this project, we'll be just demonstrating a normal DOL. So we're gonna need digital inputs, we're gonna need digital output. And then we declared our variable. We have a start button, stop button, e-stop, overload, and a motor. In this basic that we wanna do, we have right-clicked under logic and created a section. We named it a pump, and then this uh, programming view came in our vicinity. And then now I'm gonna right click. Oh, before we go through the right click, let's check. We want to do a simple DOL in this demonstration. By the look of things here, for me to get power to this coil, if I may speak in terms of logic, I would have to press the start button or have the latch on in order for power to move through this line. So it will be start or latch and overload, which would be a not overload, not stopped, not e-stopped, then the coil will be energized. What am I saying? Start or latch, not overloaded, not stopped, not emergency stopped, then this will be energized. Now, as we have discussed in the previous lesson 3, we spoke about gates in their entirety. Then we're going to come back here. I said or, then I'm going to look for right click and then function input assist, and then I'm going to just say or. Then I'm looking for an or gate, and I'm going to paste my or gate there. And I spoke a lot of ends. I'm still going to right click FBB input, and then I'm going to say end. Then I'm going to get an end gate and then put it there. So these are the two main things that I spoke about when I was trying to do the logic. Now, how many ends did I have? I said start or latch and number 1 and number 2 and number 3. Now I'm gonna go come here. So I must have start or latch and not overload and not stopped and not on emergency stop. Thank you. And then now I'm gonna double click there and then insert I said is start and I said or latch, which would be the normally open of the motor. And then this one I'll click here. Sorry, I'll click here. Sorry, okay. Doesn't want, we can go there and look for a link. And then we come back, click on that and link it with that. And then right click to remove that. And then I said double click there. I said not overload. And then double click there and say not stopped, and then double click there and say not stopped under emergency. But now this I said not, and remember for not we must have a not. Then I'm gonna come right click there and negate this pin. And I say negate, there's a O there, that means not. Then right click there on that one again, put the not, click, right click there, not, and then I'm gonna have the motor, which is our coil. Then Let's build the project. Yes, the project is built. Let's connect to the PLC. We are connected, and then transfer this into the PLC and run the PLC after. Okay. Then as it downloads, and then we are on running mode. As you can see, everything is red to show that it's not high. Then you come and you click your start button, set it high, and then the motor get energized. Start button, as you released, it goes back, the latch is on. It maintains the on signal to the output of which is the motor. Now it happens that we experience an overload, the motor will stop, and the overload get resetted, and then we have to come back and start. The motor will start, and then the start button gets released, and we press the e-stop, the motor stops, it gets released, we come back and start. That's function blocks. As you can see, we use two gates, OR gate and AND gate. Thank you very much, and we're gonna do the derived function block on our next lesson. And please subscribe to our YouTube channel. Thank you.